because we'll be working with this for a while. So right here we see a market equilibrium. We're putting together the supply and the demand curves. So when supply and demand curves cross, right there is going to be the market equilibrium, where the number of goods produced by firms is the number of goods demanded by consumers. Those are going to equal each other. So there's no incentive, nothing encouraging firms to make more or less, or people to buy more or less. So if that quantity, whatever that quantity is, where those two curves cross, is going to be the equilibrium quantity. And that price at that point will be the equilibrium price. So for instance, in this market, it's going to be, equilibrium price will be $350, and the quantity will be 5. In this case, it's like 5 million smartwatches per week. So I mentioned last time that producers would prefer to sell at a higher price. Consumers would prefer to pay a lower price. But because of the competitive pressures, they're forced to buy and sell at this equilibrium price if they want to be able to actually continue to buy and sell these products. And if firms price too high, it'll be great for them, but consumers aren't going to want to buy the products. So in order to actually sell those products they've already produced, they'll have to lower the price, moving the price down towards equilibrium. Yeah. So here's a look at a firm prices a good too highly. Let's say $400 when the equilibrium price is $350. You end up with a surplus of smartwatches. So again, the firms will, at $400, it'll be worth it for them to make 6 million smartwatches. So more than the equilibrium quantity. And remember, that's because resources that are used to produce smartwatches, or whatever product we're looking at, are going to cost more money as you use more and more of them. So as you produce more, your labor costs are going to increase. The cost of the actual raw materials you're using that could be used for something else, that's going to increase. You have to bid them away from competitors. So in order to produce more, firms are going to need more money. Now, at this price, at $400, consumers are only going to demand 4 million smartwatches per week. So we end up with a surplus. We have extra smartwatches sitting on shelves that people are unwilling to buy at that price. So what ends up happening is goods end up piling up. They're sitting on shelves unsold, and firms want to recoup the money for that. So they'll be willing to lower the price they sell at in order to get those off the shelves, get some revenue for them to make up for it. As they lower the price, they move from 400 down towards 350. More consumers are going to be willing to buy. So right there, as we move down, we'll be at that point. So the quantity made will increase from 4 million to say 4.5 million. And as firms keep lowering the price to get those excess goods sold, consumers are going to demand more and more until we get to that 5 million smartwatches per week, that equilibrium quantity demanded. At that point, the firm's not going to have any pressure to decrease the price anymore. Okay, so this sounds kind of naive, right? Like in the real world, this process working out. But we've actually seen this somewhat, we see this happen all the time, but a very clear example of it was airline deregulation back in the 70s. So up until like the late 70s, there was basically a government board that set prices for the airline industry. It set the routes. It basically didn't allow competition between the different airlines. It basically told them what to do, what prices to use, that kind of stuff. Now I'm blanking. Stephen Breyer, he's now a Supreme Court justice. Before that, he led the charge for deregulation. He convinced Senator Ted Kennedy to convene some hearing on Capitol Hill. And Jimmy Carter actually campaigned on removing this, like the price fixing. What happened eventually, after several years, the price fixing setup, organization, whatever, was removed. And these airlines were able to begin competing with each other, offering whatever routes they thought were more efficient, and they were able to change their prices. At first, the firms, the airlines held steady. They didn't lower their prices. Anyone who's flown knows how shitty airlines can be. This wasn't any different back then. But eventually, some smaller airline wanting some more market share cut their price just by a little bit. And then another smaller one, trying to get some market share, cut their price by a little bit. And then one of the big ones cut their price by a little bit. And what we've seen by today, the average airline ticket costs almost half as much as it did back in 1970 when you adjust for inflation. So we had this cascading effect of competition, forcing consumers, or forcing the producers to lower their price towards the market equilibrium. Okay. So now let's look at the opposite situation when there's a shortage of goods. So say firms, they don't know the equilibrium price, they don't know it's $350. So say they set the price smartwatches at $250. When they do that, okay, price of $250, trace out the demand curve, that has been 7 million smartwatches that consumers demand. At the price of $250, a lot of people are willing to buy smartwatches. But you look at where the $250 crosses the supply curve, only 3 million smartwatches are made in the rest of the market by firms. Firms aren't willing to spend more money producing more smartwatches because of the cost of resources, cost of materials, of labor, that kind of stuff. Because the supply curve is basically the marginal cost curve for a firm. What we end up with is a shortage, in this case, of 4 million smartwatches. So for those consumers that are able to get a smartwatch for $250, they're pretty happy because they got a good deal on this. But there's 4 million people that are left out of the market, unable to get those smartwatches. What's going to happen is once the goods start flying off the shelves, the seller's going to realize they can increase the price of smartwatches and they're not going to lose any consumers. So they'll slowly start increasing the prices they're going to charge, which sucks for the consumers at first, but as we increase the prices, as we move up from 250 to 350, we're moving along the supply curve, firms are going to be able to supply more and more smartwatches because now they're recouping more money for it. So it's worth it for them to use those resources to produce smartwatches. And as they do that, fewer and fewer people are going to demand smartwatches. For them, it's not worth it at a price of $300 when it might have been at $250. And that process is going to continue all the way up until they reach equilibrium. At that point, the firms have no more incentive to cut their prices or to increase their prices anymore, to increase production. If they did, they'd end up with a surplus of goods. And again, we do the same thing that happened on the previous slide. All right, we covered that last time about how it's the interaction of buyers and sellers. Because in a competitive market, there's many buyers and many sellers. Because each of them is trying to get the goods and services they want, or trying to get revenue, trying to sell those goods, they're going to compete against each other, and that's going to help move the market towards equilibrium. We'll talk later about markets where there's fewer buyers and sellers, and the problems that can cause, and difficulty towards reaching equilibrium in those situations. But for most markets, what we see is they're competitive with a lot of buyers and sellers. Like I've mentioned in this class before, in real time, it's very difficult, almost impossible to understand or to estimate what the supply and demand curves are. We don't know what shape they are, whether they're a flat line, whether they're curved, how steep those curves are. We can usually get an idea where the equilibrium is, but that doesn't matter for the models we're working with. Basically, what we're trying to do is understand what's going to happen to price and quantity based off of changes in the supply and demand curves. So this might not perfectly capture what's going on in the real world, but it's a model to help us understand what's going on. And I'll have a quick video explaining equilibrium.
In this video, I want to review just a little bit equilibrium and the adjustment process. Ordinarily, we won't be doing much review in this class, since you can always go back and rewatch a video. But in this case, I want to emphasize a few points, and the material is very important. So let's review, but we'll do so quickly. Okay, here's the equilibrium price, the price where the quantity demanded is equal to the quantity supplied. Why is that the equilibrium price? Because if any other price forces are put into play which push the price towards the equilibrium price. So at a price of $80 per barrel, for example, we would have a surplus. The quantity supplied would be greater than the quantity demanded. Sellers have more goods than they have customers, and because of that, they have incentives to push the price down towards the equilibrium price. What if the price is less than the equilibrium price? Well, in this case, the quantity demanded will exceed the quantity supplied. Buyers will want the good, but there won't be enough of the good to go around. In other words, there'll be a shortage because the buyers have to compete to obtain the good. They're going to push the price up, again, towards the equilibrium price. The equilibrium price is the only stable price. Through a similar kind of argument, we can show why this quantity, the quantity such that quantity demanded is equal to quantity supplied, why this quantity is the equilibrium quantity. Namely, choose any other quantity, and let's show that that can't be an equilibrium. So suppose that the quantity bought and sold was 50 million barrels of oil per day. Notice that for this last barrel of oil which is being bought and sold, buyers are willing to pay up to $90 for that barrel of oil, or for one more barrel of oil, they're willing to pay $90. On the other hand, sellers are willing to sell that barrel of oil or one more barrel of oil for just $50. So there's a big potential gain from trade here of $40. Indeed, for any quantity below the equilibrium quantity, there are unexploited gains from trade. Now in economics, we assume that if you put a potential gain from trade in front of people, they're going to find it. They're going to be able to realize that if only they bought and sold a little bit more, both the buyers and the sellers could be better off. So that's why we assume that the quantity bought and sold will be pushed to the equilibrium quantity, because it's only at the equilibrium quantity that all the gains from trade have been exploited. Okay, in a free market, could the quantity bought and sold be greater than the equilibrium quantity? Well, not for any significant period of time. Imagine, for example, that 90 million barrels of oil were being bought and sold. Well, for this last barrel of oil, the suppliers are willing to sell that barrel of oil for $90. That's their cost. They require at least $90 to stay in business and sell that barrel of oil. On the other hand, buyers are willing to pay for that barrel of oil only $50. So there's a lot of waste going on here. Suppliers are spending more to produce the barrel than the barrel is worth to buyers. Indeed, at any quantity above the equilibrium quantity, there's waste. And we don't expect waste to last very long in this market, precisely because if without any intervention, suppliers are not going to be able to sell a product to buyers for more than the buyers are willing to pay for that product, for more than the product is worth to the buyers. So for this reason, we don't expect waste to last in a free market either. So a free market maximizes the gains from trade. Remember also that the gains from trade can be broken down into two parts, the consumer surplus and...
We'll talk about consumer producer surplus in the next section. I just like that marginal revolution video because they focus not just on prices like the textbook does, but also on the quantities that are being produced and highlighting gains from trade. But for your exam, it'll just be what we go over from the textbook. So if the price is too high, what's going to happen? If the price is too low, what's going to happen? How's the market going to move back in equilibrium? But I thought it was useful just as another way to think about it. All right, so this graph here shows the market for smartwatches before Apple enters the market and begins producing smartwatches. So once Apple enters, this is increasing number of suppliers. So what it's going to do is shift the supply curve to the right. So as we increase the supply curve, we shift it to the right. What that's going to do is, at any given price, it's going to increase the supply. Now, if we stayed at this initial price, at P1, what happens, we would have a much greater supply. Because we're now putting together supply and demand, it's going to be where the supply curve, the new supply curve crosses the demand curve. So the price is going to decrease and the quantity demanded is going to increase. So how much exactly is price going to fall? If we're looking at a real market, trying to understand the real market, not just an example that has some numbers that are given to us, we're not sure how much the price is going to fall or how much the quantity is going to rise. We need more information to be able to do that. So for now, when we talk about these supply and demand curves, and we understand, or we look through what they're doing when they shift, you can only talk about the direction. The price will increase, quantity demanded will increase, things like that. So if you look at what actually happens, like the process of when a new firm enters, so initially we're selling at P1. Then a new entrant enters the market, and they begin selling, in this case, with smartwatches. At this new price, there's going to be a surplus. There's no, quantity actually being supplied by producers is going to be Q2. It's going to be higher than equilibrium. So what these extra units are going to do is drive down the price. We're going to move along the supply curve, back down to the equilibrium price. So now an increase in the supply of goods, a shift in the supply curve to the right, is great for consumers. So they end up with more goods than before and at a lower price. Another example of this is the improvements in technology since the 1980s. We've seen the usage of computers and the internet a lot more in businesses than just 20, 30 years ago. And that's been able to increase productivity for firms. So you shift the supply curve to the right. So for a lot of businesses, we see either prices falling or the quality of the goods increasing and the price staying the same. So here is a supply curve shifting to the left. So supply decreasing. You guys give some examples of what might happen, what might cause the supply curve to decrease. What's causing the shortage? Coronavirus, lack of resources. So in the 1970s, we had a supply shock of oil. OPEC raised the price of oil. So we had a supply shock then, a supply curve shifted to the left. Coronavirus has disrupted a lot of supply chains and shut down businesses. So we've had a supply curve shift to the left for some goods and services. Other examples are war or natural disasters. You might have a drought that decreases the supply of crops. And a war just destroy factories. So what's going to happen in these situations? The supply curve shifts to the left. We end up with the price increasing from P1 to P2 as we move from the original supply curve crosses the demand curve to where the new supply curve crosses the demand curve. And the quantity demanded is going to decrease because of the higher price. So which is going to leave consumers better off? An increase in supply or a decrease in supply? Increase. I heard it. All right, so now let's look at the demand side. So let's suppose that consumers' incomes increase. Consumers are now better off and they have more money to spend on goods and services. What's going to happen in the market for, let's say, paper? Since paper is a normal good, as consumer income rises, the demand curve is going to shift to the right. So it's going to move here from D1 to D2. So at the original price that we had at P1, we followed out there, there's going to be a shortage. So the equilibrium price rises. We move from P1 up here to P2, where the supply curve and the demand curve cross each other. We're going to end up with increasing prices and increasing the quantity demanded. So basically what's going to happen is people get more stuff because there's an increase in demand, but they're going to have to pay more for those same goods and services. All right, and finally, the effect of a decrease in demand. So we're looking at the paper market. Let's say the use of digital technology increases. People aren't writing out memos on paper to each other anymore or mailing letters. This is basically everything going through the office that no one wants to buy paper anymore. What's going to happen is the demand curve is going to shift to the left. The price, the equilibrium price, is going to fall. The equilibrium quantity is going to fall as we move from this equilibrium point down to this equilibrium point. Other examples of this, there's like DVDs and Blu-rays. Demand for those are falling as more people stream movies. So we'll see the price fall for Blu-rays, trying to get people to buy it, but we'll also see the quantity demanded decreasing. All right, and here's a table you can use that summarizes how shifts in supply and demand affect equilibrium price. So supply curve shifts to the right, demand curve doesn't move. The quantity increases, the price is going to decrease. You can use these to help study. Just a quick way, I guess, to remember if you don't want to remember shifting supply and demand curves. With that, let's take a break. You guys have a random question or comment or something? All right, if not, what's something you guys think is really overrated?
LPG.
But the prices or the weak drinks?
Both.
What's something else? Anything? I mean, we can go back to like talking about this, but I figured
TikTok is overrated.
TikTok.
So
What's the deal with Instagram making like their own version of TikTok? I guess it's like Facebook. But is that something people are using? Or is it like Google Plus and it's just like going to go away after a couple weeks and nobody uses it?
it'll be a phone call.
Okay, so let's do a couple applications of this. First one is the market for fixed price event tickets. So, say a football game. So we have a demand curve, obviously downward sloping demand curve for consumers. But this is, let's use the example of a football game. This is in a football stadium. What's the supply curve going to look like?
Season.
What?
The season.
Well, let's just say for one game. Always the same. It's going to be vertical. Because there's only so many seats in a stadium. Once you fill up those seats, that's it. You can't like add more seats during a game or during a season. Let's say right here is the equilibrium price, and this is going to be equilibrium quantity that they sell out all their games. So what happens if they price the tickets too low? they price it at P1. So we end up with a shortage. We have more people actually demanding to go to the games than we have tickets available. So what's going to happen here?
Raise price of tickets.
What's that?
Raise the price of tickets.
We can raise the price of tickets. If we think of like college sports or like, let's say college football games, you often have deep discounts for student tickets. Because students don't have that much money, but a lot of students want to go. So I normally don't raise the price of tickets. Plus, like old alumni get all pissy anytime you try to like change prices or change anything about the stadium. So what's something that ends up happening? This isn't like an economics question. This is like any like sporting event or concert or something question. Yeah, you get the dudes standing outside scalping tickets. You have people buying tickets ahead of time and selling them later on StubHub for more. On Craigslist, whatever. So the secondary market emerges. And what they start doing is selling at higher and higher prices. Even though you buy it from the stadium at P1, or from like the, whatever, who's ever running the event, people buy them to sell them on like StubHub or whatever. They start increasing the price. So they start moving up the demand curve to that equilibrium price. What happens is if you buy tickets, who's bought tickets like, I don't know, like had season tickets or whatever, bought directly from the event, and who like bought them later. We'll see them online for like much higher. The reason you see them online for much higher is you have scalpers doing this. They end up charging the higher price to move the market towards equilibrium. Fewer people are willing to buy tickets at this higher price. That ends up being the number of people that can actually fit in the stadium. All right, let's work through another one. Let's use the example on the PowerPoint. Let's say consumers demand their taste for beef changes. So they end up preferring to eat less beef than before. This is going to affect the supply or demand. Demand, all right. Which way is it going to move? Is it going to increase or decrease? We have our initial equilibrium price. Curve shifts to the left. Now have a new lower price and a new lower quantity demanded. All right. It's important to talk through this to make sure we understand what's going on. Because again, we're going to be building off this for a while. So from 2006 to 2013, the price of Blu-ray players fell from $800 to about $95. And the number of Blu-ray players that people bought increased dramatically. So which of these changes do you think happened? Increase in demand, decrease in demand, increase in supply, or decrease in supply? Decrease in demand? Any others?
Oh, increase in supply.
Increase in supply? One head nod, anyone else? Yeah, so what we saw was a substantial increase in supply. We had a lot more firms enter the market and more firms producing, or each of those firms producing more Blu-ray players. So the supply curve shift way out to the right and decreasing the price and increasing the quantity demanded substantially. Because now at this newer, lower price, a lot more people are willing and able to buy Blu-ray players. And this is like the cycle that happens like all new technology. It comes out super expensive. Very few people use it. And then over time, they figure out cheaper ways to make it. More firms begin making them because of the high price they can get. And the price slowly and steadily drops to something a lot lower. Another one. What do you think is going to be worth more? A letter, an original letter written by John Wilkes Booth or by Abraham Lincoln? Abe Lincoln, you know, famous president. Everyone loves collecting, or like his collectors all love Lincoln stuff because of how important he was. John Wilkes Booth is just some failed actor, or some actor that killed him. You think Lincoln?
I would say John Wilkes Booth is probably less leverage saved by him, so that there's not a huge supply and varying space.
All right, yeah, you pretty much answered that. They had an auction a couple years ago, and Booth's letter actually went for more than Lincoln. They both went for like over $20,000 though, so it's a lot of money. Lincoln has a high demand, but also a high supply, whereas Booth has a much lower demand, or somewhat a lower demand, but also a lower supply. So because of that, you have these two curves. The price for Lincoln, this is the supply and demand curve for Lincoln. Equilibrium, the quantity is much higher. And the price ends up being slightly lower than John Wilkes Booth right there. Okay. We'll watch another video from Marginal Revolution. This is about the equilibrium model in work and some experiments that economists did in the past to try to see if equilibrium can work with just small groups of people. Also, Vernon Smith right there, he's a Nobel laureate for this work. I went to a talk he gave, I think I was still an undergrad here at the time. He will only wear a Hawaiian shirt, or if he has to dress up nice, he'll wear a bolo tie.
Now that we understand supply and demand and the equilibrium process, we can ask, does the model work? Some of the most impressive evidence was developed in 1956 by Vernon Smith, one of the founders of experimental economics. Smith actually expected that his lab experiments, which I'll describe in more detail shortly, he expected that they would disprove the model. But he was shocked when time and time again the model predicted exactly what happened. Vernon Smith was awarded the Nobel Prize in Economics in 2002. Let's take a look at what he did. Smith's first experiments were very simple. He gave a group of students, called the buyers, cards similar to these, which told them the value that they placed on a good, the maximum they would be willing to pay for the good. He then did the same thing for sellers, giving them cards which told them their costs, the minimum price at which they would be willing to sell the good. Notice that the distribution of buyer values determines the demand curve. At a price of $3.50, for example, the quantity demanded would be 1. But as the price falls to, let's say, just below $3, the quantity demanded would increase to 2. Similarly, the distribution of cards for the supplier costs determines the supply curve. Moreover, because Smith knew the values that he distributed, he could calculate the demand in the supply curves and the predicted equilibrium prices and quantity. Smith let the students make trades in a double oral auction. Traders would call out, "I'll sell for $2, I'll buy for $1, and so forth. Anytime two traders agreed to a deal, the price would be called out. Sale at a price of $1.50. If a buyer and a seller, say this buyer and this seller, agreed to make a trade at, let's say, a price of $1, then the seller would earn the price minus their cost. In this case, the seller would earn a profit of 25 cents. The price minus their cost. Similarly, the buyer would earn their value, $2.25 in this case, minus the price, $1, for a profit of $1.25. Now here was another key to Smith's market. He actually paid the traders their profits in real money. So Smith's experimental market was a real market with a real demand curve, a real supply curve, and traders who had an incentive to maximize the gains from trade. So what happened? Here are the results from one of Smith's remarkable experiments. The demand and supply curve calculated by Smith are shown here on the left. The model predicts an equilibrium price of $2 and an equilibrium quantity of 5 or 6 units. What actually happened is shown on the right. The actual market price quickly went to $2, or very close to it. The market quantity quickly went to 5 or 6 units. And we're over. Exactly as predicted by the model. The buyers with the highest values bought, and the sellers with the lowest costs sold. In short, almost all the gains from trade were exploited, leading to near maximum efficiency, exactly as predicted by the model. Another way to test a model is to examine its predictions about what happens when the demand or supply curves shift. In fact, what makes the demand and supply curve model so powerful is that you can analyze any change in market conditions using a shift in either the demand or a shift in the supply curve. That will produce a prediction about what will happen. You should be very familiar with demand and supply curve shifts. Let's run through a few examples. The key here is to understand the logic, not to try to memorize the results at every possible shift. If you understand the logic, then with a few curves, you'll always be able to duplicate and to understand exactly what the model predicts. Here's the market for laptops, with the demand and the supply of laptops. We all know that technology has reduced the cost of computer chips, Moore's law and all that. The reduction in the price of computer chips reduces the cost of producing laptops. A reduction in costs is modeled by an increase in supply. The supply curve moves to the right and down. So what does the model predict? The model predicts, therefore, that the price of laptops will fall and the quantity bought and sold will increase. Pretty good prediction. Now let's look at the market for portable generators. Let's suppose that a hurricane is approaching. What will the approaching hurricane do to the demand for generators? Well, it will increase the demand, shifting the demand curve up and to the right. What does the model predict? The model predicts an increased price of generators and a greater quantity exchange. Also, pretty good prediction. Using the simple but powerful model of supply and demand, we can also understand important events in world history. Let's look at the price of oil over the last 50 or 60 years. Here's the price of oil since 1960. We can see a few key events. In 1973, for example, OPEC first flexed its power by reducing the supply of oil in an embargo. And what you can see is that the price of oil skyrocketed. The big price increase makes sense because there aren't many good substitutes for oil in the short run. We're going to be talking more about the elasticity of demand in future videos. The Iranian Revolution and the Iran-Iraq War were also important supply shocks, negative supply shocks, which pushed up the price of oil. A higher price, however, encouraged more exploration. And as additional sources of oil were discovered in the North Sea and in Mexico, the price of oil began to fall. Another key event occurred in the 2000s, as growth in China and India increased. That increased the demand for oil, pushing up the price. For the first time, millions of people were able to afford a car, and that increased the demand for oil. You can see that increased demand continued until this big drop in the price of oil in 2008, 2009. What's that? That, of course, is the demand shock from the big recession and the financial crisis, which hit the United States and Europe especially hard, reducing the demand for oil, at least until the recovery had started to occur. What you can see here is that the simple supply and demand model provides a very useful framework for understanding our world. Thanks.
If you want to test yourself, click Practice Questions.
All right, so I think this is a pretty good place to stop. So we'll pick up next time. We'll do one more example of shifts in supply and demand curve, and then we'll go through what happens when they both shift.